I'm Kaustav, your instructor, and today we are going to talk about sharpening of images. So, if you remember in the previous video, we have talked about how to blur out the images, blurring effect in the images. So now the sharpening is exactly opposite to the blurring of images. And if you, I have also talked about the bokeh effect in the mobile phones or in the cameras that you use. So in that bokeh effect, if you see it clearly, both the things are applying blurring as well as sharpening. It blurs out whatever the background that you wanna remove the noise of the background. It blurs that out, and it emphasizes the person, basically the person standing over there. It emphasizes it. It creates a basically detects an edge and preserve the edges and emphasize on that person. So what it does is it's sharpening the person and blurring out the background. So this is what the bokeh effect is. I've already told you the methods of blurring of the images. Now we're going to talk about sharpening of images. And sharpening of images is very easy. Simple concept is nothing to, not like there are lots of methods to work with. There are some basic methods, but today we are going to discuss only one method, which is a good method to discuss in sharpening of images. So let's get into our spider ID and see what that is. Okay, so this is a program. Basically, this is the program for sharpening the images. Okay, only this much. Yeah, and if you see, we have imported two libraries, CB2 and NumPy. You know about them. Then I've read that same image which I used in blurring out the images, that Apple image. Then we have created this kernel over here with the array. We will discuss about it. Then we have used the same method that we used to blur out the images, filter 2D method. Okay, if you remember, if you watched my previous video, we have used this method, filter 2D method, to blur out the images. And right now we are using the same method to sharpen the images. Then we are just showing the original image as the filter image, using filter 2D. And wait key and destroy all windows. Nothing too complicated. Only these two things you need to understand over here. So this is our, we have created our kernel. Same thing like we have created our kernels in the blurring of images, but there was like different types of kernels we were using. But here these are some specific kernels that we use. Okay, these are like that. If you see this kernel over here, at this matrix, basically we call it. So you see all the numbers are like minus, 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 one, minus, one, minus, one, and in the center I've given just one number as 9. So if you have thought of if you have given a little bit of a mind, you would have realized from where 9 comes. It's the multiplication of length into breadth. Like earlier, people were like dividing the whole matrix with the length of the matrix with the width of the matrix. Now this time, what we are doing? This time we are not dividing it that matrix by that number. We are just putting it at the center, whatever that number is, and rest of all the numbers are -1. So one more, we get an idea with it that whatever the kernel that we are going to use over here will be odd always, odd number of kernels, so that we can find the center and when we can place our, whatever the number we want to place it. But don't limit yourself up to this point. Okay, create bigger kernels with bigger values. Okay, use like maybe make a 5x5 kernel and put a 25 in between, or 7x7 kernel and put 49 in between, and or maybe if you want to give it a more try, do -2 over here, -3 over here. Try what you're gonna get with it. Those are experiments. Work with those experiments. That is gonna make you do something better. Okay, so don't just limit yourself with this much only. This is just, I'm trying to teach you what I'm trying to make you understand what's happening over here, how we do it, sharpening the process. That's all on you, how you are gonna do it. Okay, then we have used our filter 2D method. We have called the source image. We give the depth as -1. -1 means it will use the same depth as of our original image. And then we have given it a kernel. Kernel is this, our kernel over here. Okay, and then we have I am show original, I am show filter, and wait key destroy all windows. Now if I run this program, if you see over here, and let me pull out the both images. Yeah, you see here this is the original image, and you see here this image is got sharpened up. You see the edges over here around the apple. are more clear to you than in this. And this is now, if you see these both images, you would find this original image is a little bit of a blurry image, a blurred out image a little bit, and this is a sharpened image. Now I can also, if you try to understand, if you try to relate previous video with this video, you will, if you working on this video and if you try to blur this video out, you will see how we have removed this noise that is in between and make it look plain. Okay, so this is now here we can understand what blurring really is. At that moment, I was not getting a good image, and even there was not much of a good clarification because of that image was already good shape, but still we were able to remove lots of noise from the image. But here you can see clearly that suppose this is the original image, suppose this is a blurred image, and this is the original image, this filter one. This is the original image, and this is the blurred image. Obviously, like you if you are blurring some image, you are going down. If you are sharpening an image, you are going up. So for up, that original image is a blurred image, right? The same thing. You see how much noise has been removed over here. And same thing if you see this wooden structure kind of a thing over here. Here you can't even you can't see properly, you can't find its edges, but here you can see its edges and you can find it properly. Okay, so this is called sharpening of images. Now, as I told you, work with these. Okay, make a bigger matrix. Okay, like make a 7 by 7 or 9 by 9. And remember one more thing. Every time what happens is it this filter 2D. We are working with a filter 2D method, right? So what filter 2D? Or one more thing you can try. Try Gaussian blur. No, don't try Gaussian blur. Sorry. No, those methods are not gonna work over here. Definitely. Actually, I was trying to help you with the experiment, but no, they are not gonna work. Okay. So what you can do basically is increase the size, make it 7 by 7 or 9 by 9. Or one thing you need to remember, let me run it again. Okay, these two are images. Okay, these two are okay. We have right now created a kernel of 5 by 5. So what happens is, 5 by 5 kernel, what it does, it's always it multiplies with the values of the original matrix and put it at the center of the kernel, right? So you will see the border of that original image will not be get much affected, and more the center means like center will get more affected with the whatever the method, either we are doing blurring or sharpening. Center will get more blurred or sharp than the border. Okay, so the more the border you want to clear out, the big make your kernel that big, and that much difference will be created in between. Okay, that much blurry or sharpness will come at the center of the image, then the borders of the image. So keep in mind when you are increasing or decreasing the size of the kernel. Okay, so this is all about sharpening of images. Keep practicing it. See you in the next video.